I will show you how to convert decimal to binary system using successive division and subtraction method. Let us first use successive division. Convert 344 to binary. Divide 344 by 2, and that would give us exactly 172 without a remainder. Now copy the quotient, which is 172, and divide it by 2, and we will get exactly 86 without a remainder. Copy 86 and divide it by 2, and we will get 43 with no remainder. Now copy 43 and divide it by 2, and we will get 21.5. Before writing the remainder, you need to multiply it first by 2. So that's 0.5 times 2 equals 1. And so the remainder is 1. Now let's continue by copying the whole number, which is 21, and divide it by 2. And that would give us 10.5. Again, we need to multiply the remainder by 2, and that would give us 1. Let's continue to divide the whole number. 10 divided by 2 is 5 with no remainder. Now copy the quotient, which is 5, and divide it by 2, which will give us 2.5. Multiply 0.5 times 2, and so the remainder is 1. Copy again the whole number, which is 2, divided by 2, and that would give us exactly 1 with no remainder. And finally, copy the quotient 1 divided by 2, that would give us 0.5. For the remainder, multiply 0.5 times 2, and that would give us 1. Since we already obtained a 0 quotient, let us copy its most significant digit to the least significant digit. That would be to copy the remainder from the bottom to the top. And so the binary of 344 is 1 0 1 0 1 1 0 0 0. Let's try again to convert decimal to binary using successive division. Convert 123 to binary. Divide the given by 2 until the quotient becomes 0. 123 divided by 2 is 61.5. Now multiply 0.5 by 2, and that would give us 1, so the remainder is 1. Next is to copy 61, disregard the 0.5, and divide it by 2. You will get 30.5. Since you obtained a 0.5 remainder, just multiply it by 2 and you will get 1. And so write 1 as a remainder. Now copy the whole number, which is 30, divide it by 2, and you will get exactly 15 with no remainder. Then divide 15 by 2, and you will get 7.5. Multiply 0.5 by 2, and then write down 1 as a remainder. After that, copy 7, divide it by 2, and you will get 3.5. Multiply 0.5 by 2, and you will get 1 as a remainder. Continue by copying 3, divided by 2, and you will get 1.5. As for the 0.5, multiply it by 2 to get 1 as a remainder. Finally, copy 1, divide it by 2 to get 0.5. Multiply 0.5 times 2 to get 1 as the remainder. Since we already obtained a 0 quotient, we will now copy the remainder from its most significant digit to the least significant digit. And so the binary for 123 is 111011. Now let's try to convert decimal to binary using subtraction method. We will be converting 344 to binary from the previous example to compare if we get the same answer using a different method. We will be using powers of 2 for this method. And so using a table makes it easier to show the equivalence of the powers of 2. Let's write down the powers of 2. 2 to the 0 power is 1, 2 to the first power is 2, 2 to the second power is 4, 2 to the third power is 8, 2 to the fourth power is 16, 2 to the fifth power is 32, 2 to the sixth power is 64, 2 to the seventh power is 128, and 2 to the 8th power is 256. Next is to choose from the base 2 number that can be subtracted from the given number. Since our given is 344, the highest from the base 2 number is 256. And so 344 subtracted by 256 is 88. Before proceeding to the next step, I want you to copy the base 2 number that we used so that we can check our answer later. Copy 256 and a plus sign. Then copy the difference, which is 88, and choose the highest number, which is less than 88, from the base 2 number. We will disregard 128 as it cannot be subtracted from 88. Therefore, we will select 64, which can be subtracted from 88. And so 88 minus 64 is 24. Remember to copy 64 at the bottom for our checking later. After that, copy 24 and choose the highest number that's less than 24 from the base 2 number. And so we disregard 32 and choose 16. Now let's write 24 minus 16 is 8. Don't forget to copy the base 2 number that we used, which is 16, for our checking later. Continue by copying the difference, which is 8, and choose a number that can be subtracted from 8 in the base 2 number. And so we will choose 8. Let's write down 8 minus 8 is 0. Don't forget to copy 8 from the base 2 number. Now that we already obtained a 0 difference, let us check if we got the correct answer. We will add 256 plus 64 plus 16 plus 8 to get 344. If the sum is the same with the given number, then we got the correct answer. Finally, we can identify the binary number. Since we used 256, we will write down 1. We did not use 128, so we will write down 0. We used 64, so we will write 1. We did not use 32, so we will write 0. We used 16, so we will write 1. We also used number 8, so we will write 1. And since we did not use 4, we will write 0, same as with 2, write down 0. Finally, we did not use 1, so write down 0. And now we have our final answer. The binary of 344 is 10101100. Let's compare if we got the same answer using successive division. You have the option to use either the successive division method or the subtraction method, whichever you find more convenient. Now, using subtraction method, try to convert 123 to binary. First is to create a table for the powers of 2. Feel free to pause this video. If you're done with the table, copy the given, which is 123, and select the highest number below 123 from the base 2 number. Did you disregard 256 and 128? You should use 64. And so we will write 123 minus 64, and that would give us 59. Don't forget to copy 64 from the base 2 number for our checking later. Let's continue by copying the difference, which is 59, and select the highest number below 59 from the base 2 number. Did you choose 32? Then you are correct. Let's write down 59 minus 32, and the difference is 27. Now copy 32 from the base 2 number for our checking later. Now copy the difference, which is 27, and select the highest number below 27 from the base 2 number. Did you choose 16? Excellent! And so 27 minus 16 is 11. For our checking later, don't forget to write down 16 below. Continue by copying the difference 11 and choose the highest number below 11 from the base 2 number. Did you choose 8? Then you are getting the hang of it. Write down 11 minus 8, and that would give us 3. And for our checking later, don't forget to write down 8. Next is to copy the difference, which is 3, and find the highest number below 3 from the base 2 number. Did you choose 2? Then you are doing good. Write down 3 minus 2 equals 1. Don't forget to write down 2 below for our checking later. and then copy the difference, which is 1, and select a number that can be subtracted from 1. Did you choose 1? Very good. Now write down 1 minus 1 equals 0. Before identifying the binary, let us check if we got the correct answer. Let's add up 64, 32, 16, 8, 2, and 1. If you got 123, the same as the given, then your answer is correct. Finally, for the binary, let us complete the table by writing 1 below the base 2 number that we used. And so we use 64, write 1. Same as with 32, write 1. And also 16, write 1. Same as with number 8, write 1. And 0 below 4 since we did not use it. We use 2, write 1. And 1, write 1. And so the binary of 123 is 1111011. Did you get the same answer? Let's compare our answer using successive division. You can use successive division or subtraction. Choose the method that's easier for you. Congratulations for unlocking another skill by converting decimal to binary.